Hello guys, what is up? And today we're going to be proving a formula for the area of an ellipse. So to illustrate what I mean, let's start off by drawing a plane. And then some ellipse over here. It's not the best hand-drawn ellipse, but okay. And let's call this point a comma 0. The vertices are a comma 0 minus a comma 0, and then b comma 0, negative b comma 0. And we have the length of the major axis as a, and the length of the minor axis as b, and we wish to derive a formula for the ellipse. Okay, so first we start off with the equation. We know that the equation for this ellipse will be sorry. We know it will be x squared over a squared plus y squared over b squared is equal to 1. Where, of course, 0, 0 is the origin, a is the major axis, and b is the minor axis. So what I want to do now is I want to get this in terms of y. We can do so by multiplying both sides by a squared b squared. Similarly over here, multiplying both sides by a squared b squared, we get b squared x squared plus a squared y squared is equal to a squared b squared. Okay, we bring the b squared x squared to the other side, and we get a squared y squared is equal to a squared b squared minus b squared x squared. A squared y squared, we now factor out a b squared over here, and we get b squared times a squared minus x squared. And now we divide by a squared and take the square root. So y squared is equal to b squared times a squared minus x squared, a squared. So I'm just showing all the algebra so that you understand every single step I'm doing. So by simply taking the square root, now we can get that y is equal to plus or minus b root a squared minus x squared over a squared. Okay, so we have the equation of ellipse in terms of y. But we see that it's not a function because obviously the ellipse is not a function. This is because every abscissa point will have two ordinates. But we do note that if we take b root a squared minus x squared over a squared, we'll get the curve for the top half of the ellipse. And now this provides an easy result with integration. Specifically, we see that if we take 2 times the integral from negative a to a of b root a squared minus x squared over a squared, we will actually get our result, because b root a squared minus x squared over a squared is tracing this curve over here, and obviously the integral of that will give us this. And since the ellipse is symmetrical about the origin, we know this area is exactly equal to the bottom area. So if we evaluate this integral, we'll get our answer. Okay, so now we can proceed by doing maybe a trig sub. We see an a squared minus x squared, and we immediately think that we should substitute x is equal to a sine theta. This works because a sine theta is in the domain of x, so we can do that. It becomes 2, and remember to change your bounds. We have negative a is equal to a sine theta, and a is equal to a sine theta. So we have sine theta is equal to negative 1, meaning theta is equal to negative pi over 2. And we have sine theta is equal to 1, meaning theta is equal to pi over 2. Let me get an eraser. Okay, and then now just the regular stuff. B root a squared minus a squared sine squared theta over a squared. I'm making a lot of mistakes. And then, okay, if we substitute x is equal to a sine theta, we get dx is equal to a cosine theta d theta times a cosine theta d theta. Okay, now what? Root a squared minus a squared sine squared theta over a squared. We factor out an a squared in the numerator. We get a squared times 1 minus sine squared theta. A squared cancels, and we're left with root 1 minus sine squared theta. That's cosine squared theta root, which is cosine theta. Right? So this can simplify to 2 negative pi over 2 to pi over 2 b ab cosine squared theta. Okay? D theta, okay. Now we can bring the AB term, since they're constant, we can bring it out of the integrand to get 2AB from the integral from negative pi over 2 to pi over 2 of cosine squared theta d theta. And now we see this is, we're at the home stretch. All we have to do is integrate cosine squared theta. I mean, this is easy to do. It's just integral of 1 plus cosine 2 theta, break it up into two integrals, and then it's easy from there. But we'll just use the formula here. It's theta over 2 plus sine 2 theta over 4. Of course, under the balance, negative pi over 2 to pi over 2. Okay, so it becomes, finally we just evaluate this, this becomes 2ab times pi over 4, and then sine pi is 0, so we don't even have to worry about the sine 2 theta over 4, minus negative pi over 4, and then sine of negative pi is also 0, so we don't have to worry about that. So this is what we get. This is 2ab times pi over 2, or pi ab, which is indeed the formula for the area of an ellipse. I hope you guys enjoyed this video. Make sure to subscribe, leave a like, and until next video, see you guys.